need it though, because it's going to make the muscles of our intestines be able to push the food forward. You don't want to have, let's say, a lot of fat in your diet and it's going to sit there, nothing's going to push it, because some of that fat can also cause colon cancer. When you have a fatty diet, there's going to be, like, say, carcinogens in there that can cause cancer. So you want to make sure that we could push things out of your system too. You don't want it to sit there. So we still need the other things, you know. Just one thing about fiber is we're supposed to get about 30 to 35 milligrams a day. The average person only gets 7 milligrams. So we need to put more of that in our system. You know, I know a lot of people don't want to talk about, you know, feces and stuff, but it's, you know, we're anatomy and physiology, and you're going in the health field. You want to be regular. You don't want to be going to the bathroom once every 3 days, right? You want to get it out of your system, okay? And just absorb what you need to do. So you got to have roughage. You got to have fiber. Most fiber in foods-wise, the cereal gets there's a lot of fiber in cereal, but there's a lot of sugar in there too. You know, salads. I mean, yeah, but there's not enough fiber. You're gonna have to eat a lot of salads for something like that. That's why a lot of people would have, was it Mucigen or something like that? Was it Mucigen, where it makes you go to the bathroom a lot? It also stops coughing too. You know, I go, oh, whoa, you got so if you have a coughing spell, you can take that. All right. So lipids. Now, there's a lot of different things with lipids. Lipids is triglyceride. A triglyceride is going to have a molecule of glycerol, and then we're going to have 3 long chains of what we call fatty acids. So what this looks like is this, okay? And these aren't really long because it's, just showing us just a run-of-the-mill kind of structure. But these could go like 30 carbons long. This has a lot of energy, potential energy. But unfortunately, like a Snickers bar, which is loaded with this stuff, we're not going to eat a Snickers bar and run a marathon. So you're going to eat a Snickers bar and then come to class, and since you're not using much energy, you know, moving around, this will turn into fat because you can't get rid of it, so it goes into fat. You see what I mean? They also say Twizzlers. There's no fat in there. There's no Well, you know what? It's sugar. And that sugar, if you don't use it, it turns into fat. Just be smart about the food that you're eating, okay? Yes, they're not lying, but they're misleading, okay? These are long chains, okay? So again, carbons, 4 bonds to each carbon. Hydrogens are there, making this an organic substance, okay? Now, we got to talk about single bonds and double bonds because we got to talk about the different types of fats. Now, in this case here, this fatty acid has single bonds with these carbons. The carbons here have single bonds. Therefore, we can only put a hydrogen up here and a hydrogen down here because this carbon has to have 4 bonds. But in that case, this fatty acid, this lipid over here, is loaded with hydrogens because there's all single bonds there. So we say that this is saturated with hydrogens, so we call this a saturated fat. Does that make sense? Okay? So, saturated fats, they're saturated hydrogens because there's no double bonds between the carbons. It makes for these linear structures. They go straight. They're more difficult to break up. Why? Because if we have an enzyme, lipase is an enzyme that's going to break lipids. We can only take, let's say, a lipase can only attack here and can attack here. But it can't get in here. It can't get in here. You see what I'm saying? It's too tight. So they're difficult to break up. So what happens to these is that a lot of these fats turn into cholesterol, and they go into places they don't supposed to go, like in the walls of your arteries. Okay? Saturated fats are more of your solid fats. Things like butter and lard, that kind of stuff. Okay? Now, let's go back to that picture. Come on. Okay. And let's talk about what happened here. Look what happened. I put a double bond here. With one double bond, look what happens to the structure. It bends. It's just the nature of what happens. Chemistry, you'll understand that they'll have these little molecules that you actually put together and stuff, but it bends. And that's a crucial thing to understand. When this bends, we can't put a hydrogen there and we can't put one there because it's, you gotta, there's 1, 2, 3, 4. 1, 2, 3, 4. So this is less saturated or unsaturated of hydrogens. And when it bends, it's beautiful. I can have lipase coming on this side and that side. It's easier to break down. So unsaturated fats, there's less hydrogens there because of the double bonds. Now, if you have one double bond in there, we call it a monounsaturated fat. If you have more than one, then we say it's polyunsaturated. Now, it doesn't just, like if you see my fingers here, there's three, we'll say there's fatty acid, fatty acid, fatty acid. What happens is if there's one double bond there, it'll bend. If there's two, then let's say all of these have double bonds on. I can't really do it because my fingers don't go that way. They start creating this kind of thing, a three-dimensional thing. So now it's not just it opens this way, it actually will turn into a big creature like this, and we could actually have lipase going all over this and just chew it away. So the more double bonds, the better off it is.
So there's more surface area, right?
Exactly. More exposed surface area, yeah. Okay? So of this, which one is the easiest to break down? A polyunsaturated fat, a monounsaturated fat, or a saturated fat? Polyunsaturated. That's what you're looking for. Starting to sound like a Dr. Oz kind of talk, right? How you can apply this stuff. Now these foods are easier to break down, and these unsaturated fats are easier to break down, and these are more of your vegetable oils. Corn oil, olive oil, those kind of things. Olive oil, that kind of stuff. Those are the better for you. Okay? Now, we need to discuss a little bit more about this because there's stuff out there in ShopRite and all these places that you still need to be aware of. Okay? Again, it's showing it like this. Notice what the double bonds do. These are all single bonds. There's a saturated fat. Here's an unsaturated fat. It bends, and they're easier to break because of that. Okay? Now, let's talk about this thing. Remember, carbon gets 4 covalent bonds. So I'm going to show you one area of one fatty acid and one area of a different fatty acid. These are long chains, but I'm kind of focusing on the double bond area. Carbons get 4 covalent bonds to it. And with carbons, the double bonds, we could actually put the hydrogens, since only 2 can go on here and 2 could go on there, we could still put them in 2 different places. This will alter the molecular structure royally. For instance, we could put another hydrogen there, and we could put one there, on opposite sides. Or we could actually put one there, and we could put one there, on the same side, like sisters. Okay? This is where I'm going to teach you about things called a trans fatty acid versus a cis fatty acid, which I'm sure all of you have heard about. Again, a Dr. Oz kind of talk. A trans fatty acid, like transatlantic, they're on across from each other. Cis fatty acid, just think of sisters right next to each other. Now one of them is still bad. They will still bend. I'm not going to lie to you. The double bond is still going to make a bent structure. But one is a very slight bend and the other one is a very big bend. So here's a trans fatty acid where they're on opposite sides. In this case here, there is a bend, but it's still a very linear structure. So they kind of act like saturated fats. In a place where there's a cis fatty acid, they have an almost 90-degree bend. These are the ones you want. All right? So trans fatty acid, they're very similar to saturated fats. They will increase your heart disease. These are the ones that are like the processed kind of butters. Margarine. I can't believe it's not butter. Those kind of things are going to be filled with trans fatty acids. The cis fatty acids, that's the ones you're really looking for. That's going to be olive oil and oleanic acid, omega-9s, fish oils. This is what you want in your diet, because these are the easier ones to break. Okay? Be careful the foods that you buy at ShopRite. They're very misleading. They're going to say, you know, this is what we should do on the box. We should say that it's going to be low in trans fatty acids. You see that all over. So you say to yourself, well, geez, I'm going to get that. Yeah, but read the side where the nutritional facts are, because it's probably loaded with saturated fats. They don't say that. They just say there's no trans fatty acids. You can't assume that it must be loaded with this. They probably have none of these, and they probably loaded with saturated fats. Why? Because saturated fats taste so damn good. Cholesterol tastes so good. All right? Think about this. Cis fatty acids. They have mayonnaise that is made of olive oil. Taste it.
True.
All right? You don't want to have fish oil and mayonnaise. I'm always conscious about when I was, as a doctor, I would never eat tuna and fish when I'm going to see patients. It's that breath that you get. You can't help it. If I'm going to do lab, I'm always concerned about, I'm not going to eat the pizza with garlic on it. I'm going to be here with you guys. That's what I'm saying. You can't make mayonnaise with fish oil. Well, I guess that would be okay if you're going to just use that for tuna fish, right? That feeds the purpose. All right?
Well, I thought they said they no longer make food with trans fat anymore.
No, I think they still do. Can't help it. I mean, you still get margarine, right? You still get, I don't think those companies went out of business.
No, it's way cheaper.
But,
Yeah.
but when you read the nutritional value,
All right? So you're going to have a glycerol molecule here, and then you're going to have a fatty acid that's going to be here and here. That's the same thing as what I did for you here, right? You don't want to have your body devoid or without any kind of fats. You do need fats. You just don't need an obnoxious amount of fats. I mean, that's what's based off of our, like phospholipids. You need lipids. You need something in your body to make cell walls and cell membranes and stuff, amongst other things. Steroids, cholesterol. Yeah, you need that because it's going to make the steroid hormones and stuff. But with cholesterol, a little bit, side note on that, your body can make cholesterol. As you've seen, this stuff can be turned into cholesterol. So your body can do that. So you just don't need an obnoxious amount of it. Cholesterol tastes good. I have high cholesterol, I'll be honest with you. Now it's on tape, but but I have high cholesterol, I'm Lipitor and stuff. But, I try to still watch what I'm doing. So I like the cholesterol. I like my cheeses and hot dogs. But now I just moderation. I'm not going to have that much. I'm not going to have a hot dog and just layer it with cheese and stuff. I love to do that. But, just look for, let's say, low cholesterol foods. It's still there. So I'm having, that's my negotiation with the food department. I've got to, make me a little happy kind of thing. All right? So that's what that is, what I kind of drew for you. Okay? And you can see it all in here. And cholesterol and other steroids, all right? Not so much, just understand that steroids and cholesterol are part of the lipid and fat family, okay? We need those in here. Cholesterol, as you know, cholesterol is also found in the membranes of cell membranes. Remember, cell membranes, it's a fluid mosaic, so normally it'll be like this. It'll be very baggy and flappy and stuff. So we got to put at least 20% of the phospholipid bilayer, the cell membranes, have to have cholesterol, so it gives it some rigidity. All right? So we have to have some cholesterol going in there. But your body does make cholesterol. There's like 4 rings to it, and testosterone, estrogen, that's all based on steroid. They're steroid hormones, so we still need them. Okay, the last thing I want to do is just this miscellaneous thing called nucleotides, ATP, and nucleic acids. Okay? So, what is a nucleotide? A nucleotide contains 3 parts. There's going to be some nitrogenous base. There's going to be some structure that's going to have nitrogen in it. Okay? And it's called a base. And we talked about the 5 different ones if you include uracil. Okay? There has to be some sort of sugar, which is going to be a monosaccharide, and there's going to be some sort of phosphate group to it, either 1 or more, usually up to 3, but that's about as far as we go. So let's talk about adenosine triphosphate, ATP, which is what is AMP and everything that we're going to be doing for the rest of your college and medical career is based off of ATP. If you don't have ATP, you're dead. So we got to make sure that the mitochondria get what it needs. ATP is the best known nucleotide we have. MUO means made up of. So it's made up of a nitrogenous base, which is adenine, a sugar, which is ribose. Again, if it ends with OSC, it's a sugar. And it also has phosphate groups. 3, as the name implies, triphosphate. This is the body's most important energy thing, all right? It releases energy within seconds to do work, okay? Every time you break off a phosphate group, it releases a huge amount of energy. And that's what that is. So you can break off the first one, you break off the second one. So there's 2 doses of big energy in here. This is what it looks like. Again, I'm not going to ask you to draw it. So I kind of did in color coded, the orange, the blue, the purple. Orange, blue, purple. So here's where the adenine is the base. Here's the sugar, see it's a ring. Okay, monosaccharide. And then here's the 3 phosphate groups. 1, 2, 3. So as soon as this one, if this breaks off, what's released from here is energy, huge amount of energy. But then the ATP turns into ADP, adenosine triphosphate, 1, 2, 3, has now turned into adenosine diphosphate, di meaning 2, 1, 2. If that other one comes off, then it's AMP, adenosine monophosphate, meaning only 1's there. And we've got to put phosphates back on to create that again, and that's what the mitochondria is going to do. So again, here's our ATP. If one of these phosphate groups breaks off, there's a huge amount of energy that comes out of that. And what's left over here is ADP, adenosine diphosphate. There's only 2 here. If this one comes off, then it's adenosine monophosphate. There's only 1 there. So we have adenosine triphosphatases. ACEs, it's an enzyme. We also call it ATPase. This is what's going to break off that phosphate group. Okay? And it's going to create a lot of energy. A process called phosphorylation is the opposite. It's going to put the phosphate group back on to create an ADP back to an ATP. And we have enzymes that do this. They're called kinases, or also known as phosphokinases. These will put the phosphate back on. This will take it off. All right? So we have to have a constant supply of glucose and oxygen to make the ATP, okay? Have to. If you don't eat or breathe, you will die, okay? Keep this in mind as we study from each system for AMP1 and AMP2, because that's the major goal to make you understand what digestion is about and respiratory and so forth. It's all based on making ATP. ATP is consumed within seconds of its formation, 60 seconds. As soon as you make it, it only lasts for about 60 seconds. Your body has to constantly make ATP. The mitochondria is the one that's responsible for doing that. Even when you're sleeping or studying, it's making ATP. So an entire amount of ATP will only last for about 1 minute. Okay? Cyanide poisoning stops the ATP synthesis. That's how cyanide poisoning kills people. Okay?
What side of the gas?
Gas, yep. So you breathe it in. Yeah, people do that. But you gotta get it in liquid form too. Right? I think cyanide, you could actually inject it or
Is it
drink
fertilizer or something?
No, it's I don't know what it is now, but it's something. I don't know if chemistry can actually use it for other chemical reactions to make things that are useful in the environment. I'm not too sure, but it's
Just a weapon, probably.
Oh yeah, you can use it for you can use it for weapon too. Yeah. So yes, cyanide poisoning stops the ATP.
So it stops the production?
Mm-hmm. Goes right to the mitochondria. Yep. So, all right. Then we have nucleic acids. So if you understand what a nucleotide is, those 3 parts, then we can actually attach that part to a billion other nucleotides, and what we get is long chains of nucleotides. Basically, what I showed you in class yesterday, what an RNA is, what a DNA molecule is, the long chains of this. So we have deoxyribonucleic acid, DNA. It's about 100 million to 1 billion nucleotides long. These are long things, all right? And it's going to contain a base, either adenine, thymine, cytosine, or guanine, right? It's going to contain a sugar, which is called deoxyribose sugar. And it has a phosphate group there, but it's long chains. This will constitute genes, right? We talked all about that last week or yesterday, and we'll get more into what genetics is all about next week. Then we have ribonucleic acid, RNA, and there's 3 types: messenger, ribosomal, and transfer RNA. Yeah, question?
Yeah, in the story, what's ribosomal RNA?
That's what's going to make the ribosomes. So they're in the story I don't have it, but it's
Okay.
it's the construction people that are going to make my kitchen.
Okay.
Okay? So 70 to 10,000 nucleotides long. It depends on how long that recipe is in mRNA. It might be 2 pages, it might be 20 pages, you know? It depends on how long, on that situation. And in this case, for RNA, it's the same thing as DNA with 2 exceptions. There's no thymine, it gets replaced with uracil, and the sugar has that extra oxygen, so it's not deoxyribose, it is ribose. Okay? And it has a phosphate group. And it's going to carry out genetic instructions to synthesize proteins, which we were talking about yesterday. Okay? And it'll help assemble the amino acids. So basically, you have over here a nucleotide. All right, here's RNA, a nucleotide of an RNA, and here's a nucleotide for. Oh no, I'm sorry. This is the nucleotide for DNA. This is one for RNA, and this is your ATP. And that's what they look like. All right. Again, you won't have to draw them out. It's the concepts I want you to know. Okay. Now this makes sense. I'm hit. I've lost an electron. Are you sure? I'm positive. See, now it makes sense. All right. Questions on chemistry. That's really what you need to know about chemistry. Go back a slide. That one? Yeah. Like I said, I'm not going to ask you, just summarizing that they're all nucleotides. The ATP is one nucleotide. The other ones are nucleotides, but they're